Okay, another problem, some more fun, some more making it maths. So for this one, we're given events A and B. And the probability of A is this, probability of B, probability of A we're this. Now, again, let's draw ourselves a nice Venn diagram here. A or B has 0,7. We don't know if these things are mutually exclusive or not, but we definitely, let's just draw, and this is the beauty of Venn diagrams. Without even thinking about it, you can just go A, B, and you've got your sample space, and there's some sort of overlap. So the probability of A is 0,37, and the probability of B is 0,53. And A or B is 0,7. So in kind of interpreting, so let's just pause and go through a little bit slowly here, interpreting each of these. Probability of A is 0,37. So that means that whole thing there is 0,37. Okay, probability of B, let's do that in blue, is 0,53. So that whole bit there is 0,53. And when you add them together, so, if you looked at all of this bit over here, A or B, we would have 0,7. So we need to decode that. Basically work out what's the bit in the middle, maybe what's the bit outside, basically fill in our diagram. Now, let's start off by doing it just with our formula, because our formula works quite nicely and just says, well, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. The yellow, the blue, but subtract the bit in the middle that you've double counted. And we get given most of this information. So 0,7 equals 0,37 plus 0,53 minus P, A, and B. So doing it with our formula kind of just gets us all the way there. 0,37, that gives us 0,9. Subtract from each side. So the probability of A and B, that was written, maybe we should put a B in there, is 0,2. Now, it's useful filling in our diagram over here. So let's put in our 0,2 is what we worked out. Well, if that's 0,2 and the whole thing on the left here is 0,37, then this must be 0,17. Just pause, check 0,1. That whole A part is 0,37. And on the right-hand side, similar logic, this should be 0,33 because 0,2. So if we highlighted that whole bit, this whole, this whole bit over here is 0,53. So that kind of fits nicely. Okay, and if we add all of those three things together, well, let's just check, does that work as expected? 0,17 plus 0,2 plus 0,33, 7 over 10, or 0,7. So yes, that fits in nicely. Everything's worked nicely. Now, that whole thing 0,7, which means we know that the bit on the outside is, that's a big 0,3. So that everything needs the sample space needs to add up to 1. Something's going to happen. A or B or not one of those. Okay, so now we can look at the other questions because we've filled in our diagram. Now, we could do this like we did the first Venn diagram. We could have called this X over here. And we could have called this 0,37 minus X. And this one as 0,53 minus X. And added those three things together to get 0,7. We would have got the same answer. 2 different ways of doing it. I personally actually just think just plug it into the formula and it gets you there, or do it like that. We're using the visuals as well, so up to you. Okay, now for part 2, the probability of B not B, right? Not B not B, the probability of B not happening. So in other words, what we're looking at is, there we go, everything outside of here. So there we go. Let's highlight that in. We want everything except for B. So in other words, well, we've got the probability of B already. That was 0,53. So therefore, we want just everything else. Now, instead of adding all the other things up, we know that the probability of B not happening is just 1 minus the probability of B happening. Either B is going to happen or B won't happen. So, and they both have to add up to 1. So we just have to go 1 minus 0,53. And that will give us our answer, 0,47, I think I get. So, didn't really need to look at our diagram much for that one. Okay, let's head into the last one. And let's do it like this. And I hope that you're scribbling lots on your diagrams and pausing and scribbling and just highlighting and saying and redraw the diagram if you need to re-highlight. Put an overhead on top, something. The probability of not A or not B. Okay, so I'm going to highlight, because it's or, we can just highlight the one and then highlight the other. So not A would be all of this space over here. And as long as we're looking at everything that's not A. So there it is. Oh, not very good at paint by numbers. Okay, so here we go. And the probability of not B, so what we're going to add in is all the not B things. So that is this over here. So now I've highlighted everything that's not A or it's not B. But now what it looks like is there's only one bit that we haven't highlighted. So again, we can use the same kind of thinking to go, instead of going 0,17 plus 0,33 plus 0,3, why don't we just go 1 minus the only bit of the picture that we didn't highlight. So 1 minus 0,2, which gives us 0,8. Now, not the end of the world if you went 0,17 plus that, you'd get the same answer. But hey, be a little bit efficient. So I think that does that one.